Hello, everyone. Thank you so much for joining us. We're just going to give a few more minutes from everybody to move over from the waiting room to here, and we're so glad to have you. Just as a friendly reminder, please put any questions that you have in the Q&A, and we will make sure that if we can't get to all of them tonight, that they will be part of our follow-up email with the recordings and the slides. All righty. Hello, everyone. Thank you so much for joining us tonight for Big Promise or Big Problems, Ethical Considerations for the AI Boom. My name is Robin Lesko, and right now I would like to take a moment for our wonderful presenters to go ahead and introduce themselves tonight and give a little bit of their background and what they'll be speaking to tonight. Maya, if it's okay, can we start with you?
Sure. Hi, everybody. My name is Maya Wolachum. I am the director of the Trustworthy Infrastructures program at an organization called Data and Society, or a research institute that studies the social and political implications of AI, data, and automation. I'll be happy to pass it on. Should I pass it on? Or yeah, okay. Maybe Mikey, you're next to me, so if you want to go ahead.
Sure, thanks, Maya. Yeah, hi, everybody. I'm Mickey McGlasson. I work at the Create Lab at Carnegie Mellon University in Pittsburgh. I'm a community data scientist, which means I do things with all sorts of different things with data, but always with the intent of community-oriented work. And our lab has a pretty long track record of doing technology work in partnership with community organizations, a lot in Pittsburgh, where we're located, but also in some cases elsewhere globally. I will pass it to Im.
Hi, my name is Em Huff. I'm a community organizer at the Mountain Watershed Association. We work in the Youghiogheny River watershed, protecting the river and its communities from past, present, and future pollution. In particular, I have an interest in air quality, data center build out, and renewable energy. Now I'll pass it to Nate.
Hi, my name's Nate. I'm also a community organizer at the Mountain Watershed Association. Like Em, I've been pretty active on this data center issue, and yeah, I have abiding interests in the fracking industry and the mining industry as well. Yeah, I will pass it to Lauren.
Hi, everyone. My name is Lauren Posey. I'm the environmental policy advocate at Protect PT. And let's see, I will pass it to Robin. I don't believe you've gone yet.
Nope, oh, you caught me. Hi, my name is Robin Lesko. I am the Western Pennsylvania Organizing Manager for Food and Water Watch and Food and Water Action. And I also manage our municipal ordinance project in Allegheny County, Pennsylvania. Have we missed anyone? If not, please shout it out.
Hi there. I'm Dane Howard. I'm a software engineer and machine learning specialist working at a company called Prescient Edge up in Tyson's Corner. And I have been in the AI field for about 5 years, and I've been a developer for almost 15.
Wonderful. Thank you all so much for joining us. All righty. Have we missed anyone else? I just want to make sure.
I can introduce myself if you like. I'm not a speaker, but I am going to be moderating the Q&A. My name is Josephine Gingrich, and I am the Health Advocacy Outreach Coordinator for Physicians for Social Responsibility Pennsylvania. I live out in the Poconos, and we do a lot of work with community members concerned about data centers and the health implications of them.
Wonderful. And Tamla, if you're on, if you'd like to introduce yourself. If not, I could give you a quick shout out too. Okay. Tamala Trussell will also be managing the Q&A with Josephine, and she is part of Move Past Plastic and of several community organizing groups. All righty, without further ado, let me move on to our first slide here. Our agenda, so setting the stage, what is AI? What are we going to be talking about? There are definitely several definitions of AI, and then also different types of AI. We'll discuss the limitations of this technology, the use and abuse of AI, the physical footprint of AI, mostly talking about data centers and their impacts. Then speaking of impacts, we'll move on to workforce and labor impacts. And then we'll end with a little bit of regulation with talking about local, state, and federal regulations and laws. And then we will round it out with a Q&A. So without further ado, let us begin. Setting the stage. What is AI? Take it away.
All right, wonderful. So I'd like to start by giving you an idea of the different kinds of AI, because common use of these terms has muddied the waters of discussion somewhat. And I think it's valuable to understand the differences between types of AI so that you can think more critically about them, especially because they have different impacts and resource requirements. So first of all, AI is any program that does something we normally expect only a human can do well, something that can't be done mechanically, or at least not obviously so. This might seem like a broad or even vague definition by today's standards, but AI has been around since the early 50s with checkers and chess playing programs. Yes, those were considered AI back then. So first, we've got symbolic AI, and you can think of these like old school AI. They're rule-based, or as we call them in the business, algorithmic. And they're complex and helpful, but they don't learn and they don't improve. Think of them like big, complicated flowcharts. All the really cool techniques are in a subfield of AI called machine learning. Click. This field encompasses all programs that learn somehow, and academics started exploring them in the late 50s with an architecture called the perceptron. The perceptron eventually evolved into the underpinning of pretty much all modern AI, the neural network. Click. And this is where we're going to be primarily focused today. The important thing to understand about neural networks in general right now is that they are adaptable in ways that symbolic AI just can't be. And they also tend to be kind of slow because they require lots of processing power. So in 2017, a new kind of neural network was developed by researchers at Google called a transformer. Click. Oh, you already did. This is the kind of neural network that everyone today thinks of as AI, by which I mean large language models like ChatGPT. Click. The GPT at the end, by the way, stands for Generative Pre-trained Transformer. So image and video generators are also neural network based. Click. And sometimes use transformers, but that's not their primary component. They use a different architecture called a diffusion model. So we're going to focus mostly on image generators and LLMs. But I want to take a second to talk about something I didn't put on this diagram, and that's called AGI, or you might call it strong AI or human level AI. It stands for artificial general intelligence. And this is a hypothetical AI, it doesn't exist yet, that can perform as well or better than a human at any cognitive task. A lot of AI optimists project AGI as being an inevitable consequence of current research and the trajectory that we're on right now. So on this slide, you can see some examples of AI you probably interact with on a daily basis. So Stockfish is a common chess AI that's been around for years. Maybe you don't see that one daily, but it's a kind of neural network. Your car's voice command system uses an AI for voice recognition, and that's a relatively small neural network. Netflix uses an AI to help recommend shows to users. In fact, virtually every online retailer does something similar to recommend products. This is old technology at this point, but it's also a kind of neural network. And here are a couple that you may not know. The magical background removal function in many of the picture editing tools around today, like Photoshop, is powered by the exact same kind of AI that does image generation. Exact same. Those silly filters on Snapchat, those are powered by facial recognition. That's usually transformers nowadays. And Google Lens uses a hugely powerful image recognition model to identify things in your pictures. Even though all these applications are neural networks of one kind or another, some are big and take lots of computation, while some are much smaller, so small that they can run on the little computer in your car. Click. So before we jump into talking about how it works, I want to briefly go over some ideas that I've read or heard about AI that maybe aren't completely true, but are commonly passed around. If you'd like to play along, try to place the bulleted ideas on the left in the region on the true to false spectrum on the right where they belong. I'm not going to pause, though. I'm going to move pretty quickly, so be thinking about it. There's naturally a little bit of subjectivity here, but hopefully I'll catch you with something you didn't know. So number one, the AI bubble will burst soon. I'm not an economist, but I do know that a bubble requires sustained hype without sustained deliverance on that hype. And if a bubble like that exists, then it's focused only on large language models like ChatGPT and the hype surrounding them. It does not at all encompass the rest of AI in the market, which is substantial. That said, I think this bubble is better understood as the claw of a much larger and much more dangerous beast that we'll sort of outline later. I count this statement as possibly partially true because while there is an argument to be made for an LLM hype bubble, it certainly doesn't cover all AI, nor does it cover the most concerning aspects of AI. So AI detectors. I'm sorry to break it to you, but AI text detectors do not work. Even in theory, modern large language models have long passed the point where it's possible to say with any reliability whether a text was written by AI or human. AI text detectors are no better than scams at this point. And unfortunately, the same is quickly becoming true of image discriminators. So yeah, almost definitely totally false. ChatGPT is just fancy autocomplete. What do you think? There's certainly truth to this statement. Functionally, ChatGPT and other LLMs do operate by predicting the next word in the text sequence. However, they differ from autocomplete by several important features. First of all, LLMs exhibit behaviors such as planning and tool use. Yes, and can even apply reasoning in a limited capacity. I know that sounds maybe a little bit far-fetched, but it is true. So I rate this statement as partially true, but deceptive, since it implies that these additional capabilities aren't worth considering. They're really the main use for these models. So most AIs are just outsourced underpaid workers. A few companies, including X and Amazon, have been caught misrepresenting their products as AI when they were in fact operated manually by a person behind the scenes. X/Twitter did this when they showcased some anthropomorphized robots that they claimed were operated by their AI, but they were in fact being operated by a human in the background who was hidden. Amazon did it when they launched their cashierless store. They had people monitoring the cameras to figure out who was entering and exiting and how much to charge them, despite what they claimed. However, this is overwhelmingly the exception, not the rule. That said, outsourced workers are commonly used to assist with training AIs, and their working conditions aren't always fair. My colleague M. Huff will cover that subject in more detail later in this presentation. I give this statement a rating of false with a grain of truth. So no one knows how AIs work. AI researchers know quite a lot about how modern AIs work, both how they learn and how they operate in a more general sense. However, models are largely made to build themselves, and the details of the technology make it incredibly difficult to understand any individual thing the model does. This is where the AI as a black box sentiment comes from, and we'll talk about that more later. Furthermore, it's also true that the people using a model typically have no idea how it works. I therefore rate this statement as technically partially true, but largely untrue of those who study the subject. Stolen data. So I've heard people claim, some people seem to be convinced that if you want to train an AI, you have to steal data. And this is categorically false. It's just not true. The companies that developed the most popular LLMs and image generators today made the choice to acquire data illegally to expedite production. They did not have to do that. Go ahead. All right, so how do large language models work? Go ahead and click. We're not going to talk about large language models yet. We're not ready. So instead, we're going to talk about neural networks, which underpin them. Go ahead and click. So a neural network is a combination of two powerful concepts from higher math. And don't worry, I'm not going to spend a ton of time on these, but they are important. The concepts are universal function approximators, which are roughly what they sound like. They can approximate anything, at least in theory, and self-correction by example. A universal function approximator is a complex mathematical operation that can, in theory, predict the behavior of any function, any pattern that you can imagine. In principle, it can approximate it. And so you'd think if we want a program that does something immensely complicated like human cognition, that's the sort of approach we might want to take. It's one possible approach, you might say. So what we need to make these universal function approximators work is enough examples of what outputs to expect or what outputs we want to get from the model for some given inputs. And over time, the self-correction process should push our approximator closer and closer to a solution with every example, a solution to whatever we want. In practice, of course, this takes a long time and doesn't always work quite the way we expect. By the way, the process of providing input and expected output in order to tune the parameters of this model is called training. When I say parameters, I'm talking about the individual neurons that make up the neural network. These individual neurons are just doing a simple calculation to answer the question, should I activate? And if they do, they pass that activation information, whatever that is, to the next layer of neurons down the line, the next group. And yes, these are loosely inspired by biological neurons, but they don't act the same way. But biological neurons do also decide to, based on their input from other neurons, whether to activate. So anyway, this information gets passed to each successive layer of neurons, combined with all the information from the previous layer, until you reach the end of the network where you have your output. And this would get translated somehow into what the network wants to produce. So each of our neurons here has two parameters called a weight and a bias. When we talk about a specific model that has already been trained, we're talking about these two numbers that every neuron has, the weights and the biases that have been tuned. Naturally, as you add more neurons, your model gets bigger, it gets slower, it takes longer to train. Go on. So here is an example of a neural network running, a process we call inference. This particular network has been trained to recognize handwritten digits, which are encoded in a very small image, just 784 bits. First, each pixel of the image is given to an input neuron, and the input neuron decides whether it should activate. These activations are passed to the next layer of neurons, which do the exact same thing, and so on until we reach the output layer. And this layer tells us which number the network thinks the handwritten digit is. When the network learns, what we mean is that the network has made a bad call. It made an error. And we took that error information and used it to calculate a bunch of tiny changes to all the neuron's parameters so that next time, when the neuron calculates the same output for that input, it'll get something closer to what we're looking for. When we do this a bunch of times over and over, the network learns to give the correct output. Now, I should stress that in this presentation, I'm glossing over a lot of details and simplifying much of what I am presenting. But if you want to dive deeper, I highly recommend the YouTube channel 3 Blue 1 Brown and his deep learning series, which is where this animation is from. Go on. So far, We've only covered what was known in the early 70s. For a long time, neural nets couldn't do much of any use. But in 2012, that all changed when a new type of neural network was created called AlexNet. This was an image classification model, much like the one we saw in our previous example. And one of their key discoveries was that if they made everything bigger, increase the number of neurons in the model, and thus the parameters, increase the amount of data available for training, and increase the time spent training, they could achieve record-breaking results. And you might fairly ask yourself, why didn't anyone figure this out in the 30 years leading up to this point? And the fact is, computational resources simply were not there. Commercially available GPUs, graphical processing units, changed that, opening the door for larger and larger models to be produced. AlexNet's groundbreaking performance, by the way, had an error rate for identifying these images of about 15%. And to give you an idea of how that compares, human experts typically get about 5%. More recent models have achieved a staggering less than 2%. Click. So now we're ready to talk about large language models. You'll notice that this does, in fact, look a lot like just picking the next recommended word in your autocomplete. The major difference, however, comes from how these models are trained. The autocomplete is trained on much less data and only ever evaluated on that next word. Modern LLMs, however, only start there. They are further trained on long passages, evaluated on not just the next word, but on everything they produce until they're done. And as a result, they are internally modeling much, much more than just the next word. They're modeling whole stories, conversations, and sequences, and with far, far more examples to work from. Recent studies by Anthropic have confirmed this fact. They aren't just predicting the next word, they're choosing the next word while considering the whole conversation, both in past, present, and future. By the way, a word here on this diagram that I did not define, woe is me, is tokens. This is not super important, but you can think of these just like words. If I were to give ChatGPT the prompt, what dog am I looking at? It would probably chunk that up as what and dog and am and I and look and ing and at. It's almost the same thing as the number of words in your prompt, but not quite. Anyway, another thing I want to point out is that ChatGPT, 1.8 trillion parameters. This thing is unimaginably huge. And that comes with some issues. Primarily in training. How long does it take to train those trillions of parameters? It can take months. Months. Anyway, click. Yeah, and that's months, even considering that you have a giant supercomputer or many giant supercomputers in a big data center. So this is my AI optimism slide, because I'm going to tell you about all the good things that AI is doing right now that you might not be aware of. Later on, we might subvert that a little bit. So get your good feelings in now. So specialized LLMs can now significantly outperform solitary physicians at patient diagnosis. Yeah. Always get a second opinion, by the way. The 2024 Nobel Prize in Chemistry was awarded for the development of protein folding prediction partially by Google. Which is an enormous breakthrough for biological and medical research, opening the door for personalized treatment in ways that we've never seen before. Specialized models are being applied to materials science research, which is itself in a golden age for other reasons, to discover new fuel cell materials, alternatives to lithium for batteries, and new kinds of solar cells. We're talking at the molecular level. New models are assisting in the fight against climate change by predicting weather-related disasters, tracking icebergs, and mapping deforestation and ocean litter. And even more, open source local large language models that you can download today are helping to democratize technology and knowledge by automating research and coding. and these are available to anyone with a PC. This sort of accessibility has never been available to people before. And if you want resources, if you want sources, citations for each of those claims, they're in my notes right here on the slides. Go ahead and click. So we're done talking about the good stuff now. We're going to talk about what AI can't do or how it harms us. So I mentioned earlier model error rates, that even modern algorithms can't get better than or won't get less than a 2% error rate on the ImageNet task. So why would we want to show off a program that makes mistakes? Is that really useful? And this is a fact that many lay people excited about the technology seem to miss often. Neural network-based AIs should never be used if an algorithm, that is a clear set of rules or recipe, can do the job. This is especially true for large language models, which generate their output with some level of randomness. This discrepancy in understanding is partially to blame for the idea of the AI bubble I mentioned earlier. Any startup whose product uses an AI where a simpler algorithm will be more reliable and less likely to fail, well, that company's going to be on its way out. It's doomed. I can't speak to exactly how many startups fit that description, but it's not zero, and it's absolutely a valid expectation. AIs of this kind will always exhibit errors and mistakes. The question is, will they make more than a person would in the same situation? If it makes fewer mistakes, why shouldn't we replace human workers with AI? This is the thought pattern behind wide AI adoption, and it's not without merit. If those mistakes cost lives, we might argue that it's irresponsible to not replace humans with AI in that instance. There are other considerations and limitations that we have to consider first, though. Click. So when does AI fail? The biggest category of failures for all AIs comes from training bias. It comes from unclean training data. And what do I mean by that? There is an implicit assumption that's baked into how training works. We have to assume that the training data is both correct and representative of reality and representative of the behavior that we want from the model. Unfortunately, it's incredibly hard to ensure that our data sets are appropriately clean. And professionals miss things all the time. When your data set is multiple gigabytes, it can be hard to go through the data with a fine-tooth comb. And to say nothing for terabytes of data. When errors or imbalances appear in the training data, that's reflected in the behavior of the AI. For example, when Apple launched Face ID on iPhones in 2017, they used an AI model that had been trained on a ton of people, a ton of faces, headshots. They didn't include, however, enough people of Black or Asian descent in the data, leading to a problem where a bunch of people could unlock each other's phones. Yeah, they got sued for that. Well, explainability is another big problem. Now that you know how neural networks work, you might be able to see that this is a major problem. Figuring out how they got their answer in a specific question is difficult, bordering on impossible. LLMs are funny because our first inclination is just to ask the model how it got its answer. But how can you know whether it's telling the truth? Maybe this will be solved in the future, but it's still unsolved now. And verifiability. This is less a limitation of the technology per se, but it's still an incredibly important consideration given that AIs are frequently meant to mimic humans. We cannot reliably determine when something was created by AI versus some other method. And this is a problem because if we see an image that depicts something important out in the world, and we can't tell whether that image is real, that could represent a danger. I'll talk more about that in a moment. The last one I want to mention is misalignment. Now, this is a little bit more subtle, a little bit more difficult to describe, so I'm going to give you an example. A Tetris AI made headlines a few years ago when it was trained just to prioritize winning and avoid losing. What do you think it did when it was faced with an unwinnable situation? It paused. and it did not unpause. That's not the kind of behavior that we want to see from AI, especially in critical situations. Click. So the theoretical limitations of AI are important to understand and talk about, but it's just as important to talk about the practical problems that AI poses due to how we interact with the technology. I'll let my colleague Maya talk about this subject in greater detail, but I'd like to mention a few points here because they're important for the thoughts I want to leave you with. First, data theft. All companies that build AIs have to confront the question, where do we get our data? All that data has to come from somewhere. The largest companies have overwhelmingly chosen to take whatever data they can, however they can, lawfully or not. Consequences be damned. The consequences, by the way, have largely come in the form of small fines that haven't done anything. Sycophancy. LLMs today are trained in a way that makes them respond positively as much as possible. Of course, you like talking to somebody who's positive. Of course, you would want your chatbot to be positive. But as a result, they tend to be sycophantic. They tend to want to give you a yes answer. So what happens when you combine a convincing, well-read sycophant with someone who really, really wants their odd ideas validated? Unfortunately, sometimes in vulnerable individuals, you get a feedback loop that leads to mental illness. In less vulnerable individuals, it's still a problem though, because you might see a reinforcement of the beliefs they already hold as they don't know how to get the model to question them, how to interact critically with it. Either way, this is a problem. And labor shortages. I bet you didn't think I was going to talk about labor shortages as a consequence of widespread AI adoption. But the fact of the matter is that experts aren't born. They're made in the first years of their career through experience working. If you replace all of your newbies with AI, your company won't produce any expert workers. You're no longer contributing to the cycle of professional skills. And once we reach a certain adoption level, we no longer have experts. Data pollution. The ease with which someone can create convincing looking false information with AI is unprecedented today. And the flood of such data entering the internet is beginning to make finding factually correct information more difficult. The most malicious form of this is deepfakes, fake images created using AI. Once, pictures were a touchstone of verifiability. We have pictures, for example, of the Nazis' death camps. We know for a fact they happened that way. We have video evidence of the moon landing. But the more deepfakes that exist, the less valid this kind of reasoning will be. And this leads me to the very last points I want to leave you with. So, unfortunately, I think everyone should be aware of these, if not talking about them. So first, the death of privacy. There's a concept in data analytics and law enforcement called path of life estimation. This is a process by which, with enough data about a person, you can essentially construct a log of everything they did on some day, or maybe week or month, without observing that person directly. This process breaks no laws because it doesn't target anyone specifically, but it doesn't need to. If data theft by companies is not punished, and data collection continues to be allowed at scale, we should expect companies to develop models that can peer into the lives of consumers with incredible and uncomfortable accuracy. From your typical Friday night habits to your political attitudes to your personalized life expectancy. Which organizations do you think would benefit most from that kind of capability? Second, a world of post-verifiable fact. As AI gets better at generating pictures and video, it will make separating truth from falsehood on the internet impossible. It won't be a post-truth world. It will be a post-verifiable fact world. And no one is ready for this. While AI carries the promise of incredible, never-before-seen potential for positive impacts on the human race and the world, it also requires that we face this ultimate question. How do we tell fact from fiction when fact-like fictions are everywhere? In the near future, here are some problems that we will see. This is not a matter of if, it is a matter of when. One, politically motivated fake videos depicting influential people doing and saying things that they did not do or say. Two, maliciously fabricated evidence entered into courtroom records. Three, scams that involve presenting the face and voice of someone you trust or someone you love, a member of your family or your boss, instead of the scammer's real face or voice. Four, law enforcement using personal path of life estimation to determine who to apprehend and when. And five, advertisement bots used to target a specific person using talking points that they know are important to that person. These are just the ones I could think of. But in many cases, they exist today. They're happening now, just not commonly. And while solutions to these problems exist, they require action at a societal level that will not come soon. Everyone needs to be aware of these impending problems because we have to do something about them. I don't know what it's going to be, but I'm hoping that everyone here can help me with that. And that's it for my section of the presentation. Thank you.
Dane, thank you so much. That was spectacular. Terrifying, spectacular, all the things. Next up, I would love to pass it on over to Maya, who is going to be discussing the use and abuse of AI. So Maya, whenever you're ready, I'm ready.
Thanks so much, Robin, and a pleasure to be here with all of you all. Thank you, Dane, for that fantastic intro. I'm going to extend some of those arguments a bit to talk a little bit more about the concerns that we have when so many of those systems meet ideas, processes, people in the public sector, unfortunately, where we tend to see some of the most impactful effects of faulty AI on people and on society. So as Dane has stated, and many others have before us, and certainly elsewhere in this presentation, there are going to be many issues with the tech itself, things like bias, explainability, data theft, surveillance concerns. But I'm a socio-technical researcher, so I think a lot about what happens when that tech actually meets people. And increasingly, one of the big questions that we have in that space is what happens when AI systems are created by private sector entities that are advertised as the very solution to big, thorny public sector problems that are much more complex than a tool could solve. Now, this is a question for a lot of debate, the role of private sector in public life. But we know that so many of these big problems are not best solved with a tool alone. Now, I'm not here to say that private sector development is always a bad thing. As Dane mentioned, so many of those models require a lot of data, often expensive computational power. Maybe it's already a company's niche to make a particular tool that fits a use case perfectly. There are some interesting outcomes that we can name. There are two on this slide. There's some interesting examples of epidemic monitoring and others where folks are using AI to monitor traffic and really find, the best place to go parking in a place like San Francisco, for example. Next slide, please. But we often find that there are many, many more examples of mismatched incentives between AI companies and the customers that they are very continually seeking, especially when applied to public questions. So to start with an example around bias and explainability, I'm going to start with an example from New York City. We have here what we call the My City chatbot. It's a very silly chatbot that Mayor Adams released back in 2023 to help New Yorkers find a way around the city resources. Essentially, if you have a question for an agency, instead of calling the city and ending up on a hotline, try this bot instead. Now, this bot was built on Microsoft's Azure AI, and it was supposed to sort of comb through the city's documents to help residents answer these questions. But most of the time, the chatbot went completely rogue, telling folks all sorts of illegal ways around the city and encouraging folks essentially to break the rules. One of my favorite examples is here on this slide where a restaurant is asking if it could serve cheese a rat had nibbled on. And the chatbot said, yeah, absolutely. Just make sure, no one can tell that rat nibbled the cheese. I don't know about you, but personally, I found that very offensive to my senses. You can go to the next slide, please, Robin. Now, that said, that is a very silly example, but I use it to illuminate that these kinds of issues, total mismatches essentially happen all of the time under the hood, though these are things that are often happening outside of public oversight and without our knowledge. On the whole, private sector companies have very, very different incentives than the public sector. The public sector that's concerned with our health, our education, our well-being, our dignity. And that's where we really run into problems on use and abuse. So there are lots of ways that other researchers have considered this. I picked 3 for this slide, and I'm sure there are many others that will end up in the chat elsewhere. But 3 considerations that I'd just like us to hold for the sake of the conversation today. One of these areas of misalignment that is really, really clear, and there was already a comment in this in the Q&A, is that private sector entities are always looking for consumers and customers, are always trying to expand their consumer base. And so as those private actors are aiming for a profit, we're going to see that these tools that have been developed for a very particular use case are being expanded over time. So you can imagine, for example, an LLM tool that's been, created for lawyers, suddenly finding its way into law schools, and then suddenly all graduate programs, and then, across universities across the country. This is a sort of mission creep that we're often finding with these AI tools in so many sectors of our economy. The second that I'd like us to hold on to is that private sector entities and public public actors have very, very different frameworks by which they're doing their work. They're subject to different rules and regulations, often varying by state and locality. So you can imagine that many of these companies that are, walking into so many of these ills when it comes to surveillance, bias, accuracy concerns are not going to be held to the same standard that you might imagine a city employee would be held to. So for example, going back to that chatbot, if you called the city and you asked them if you could serve rat cheese, they would probably say no. And that, that employee would probably have some sort of, something coming to them. But that's not often the case for these tools that are finding themselves, just often slipping under the radar of so much of our regulatory framework because, supposedly we have the trust of the private sector, which is often, not the case. And the last piece that I want us to hold on to is that, if we could imagine these as public sector tools in which, maybe someone in Harrisburg designed them, maybe we know what data has been, used to develop that instrument, we might be able to trace decisions that might have led to somebody's incarceration or health insurance denial or a hiring decision. But ultimately, because these are private sector tools in most of these cases, many of these details are considered proprietary or often trade secrets, as a colleague, Cynthia Conti-Cook, has written about extensively. So even if something does go wrong, and even if you're able to make a super clear case for the harm done, if you're able to collect a ton of data that tells you why it's harmful, it will be very, very difficult to adjudicate an algorithm or an LLM or an AI tool that you truly can't see in the public eye. And that's how we end up with so many of these especially pernicious examples that are in that sort of right word column here. Things that are, creeping in their mission, that are growing in their scope, and are finding their way into all sorts of public sector uses. So just to name a few, Clearview AI is an example that's been written about quite a bit. It was a facial recognition tool that was used very inappropriately by police departments around the country, has now been taken up by the Department of Homeland Security and ICE for the same purposes. Again, because Clearview is looking for customers, even though we know that, it has pretty horrible impacts on our society. OpenAI is another example. It's created ChatGPT, great tool for certain purposes, though is expanding its tool to, ChatGPT for educators, ChatGPT for teachers, for therapy, for all different sorts of uses beyond its initial design. I'll skip these examples for time. Next slide, please, Robin. Thank you. Okay, so ultimately the cumulative impact of this sort of private sector entrenchment is going to be deep impacts on public power, on public trust, ultimately on whatever's left of our democracy. There have been worrying trends over the past several years that I'm going to name here for discussion, but I know many other speakers are going to pick up on a few others. So just to name a few, the first trend that we're seeing here in the research and in many other ways is that, we're finding that decision-making power is being moved now very, very quickly to huge tech companies, big private sector actors. There are many key examples of this, but one that I'm going to name is redefining the meaning of fraud and abuse. Now, we have many examples from this year that I'm not going to touch because there's a really good example from 2013 that I'm going to hold on to. In that year, the state of Michigan implemented a new decision-making tool called MIDAS that was intended to find instances of unemployment fraud. In 3 years, the system found 40,000 Michiganders guilty of fraud and subsequently stripped them of their unemployment benefits. It took a long time, and by a long time, I mean like over a decade, to find that that tool had a 93% failure rate. In over a decade, victims are still seeking retribution, suffered significant emotional turmoil, and many seeking support for what became suicidal ideation. Now, retribution was won in 2024, 10 years after the harms caused in the end, but all to say, this is a really, really, really important example of what it means to move decision-making power and expertise outside of the hands of public servants who have presumably our best ideals in mind. It makes it much, much, much harder to trace these impacts over time. Next slide, please, Rob. Another concern here that Dane mentioned in his earlier section is that we are really, really chipping away at expertise by keeping things outside of public trust and public power. So, lots has been written about expertise, but it's my personal opinion that experts are experts for a reason. And they have, though there may be additional benefits added from the private sector, but we're seeing concerning trends in sectors of all kinds that we're sort of chipping away at what it means to hold that expertise in that particular space. There are lots of examples. I'm going to focus on healthcare today. That's really externalizing that vision of expertise across consumers, influencers, and AI companions. I have a bunch of colleagues, Olivia Garofalo, Ranjit Singh, and Brianna Vecchione, have been studying the impacts of mental health chatbots on users and on therapists whose work is adjusting to accommodate for this, incredible expansion in what we're calling mental health chatbots. And as they write in their op-ed and in their research, we need guardrails to protect the mental health of these users, guardrails that would naturally be a part of a clinician's process, but are getting lost in the expanse of AI tools that are attempting to match that really robust mental health care and incredible expertise that clinicians hold. Now, I'm not saying that bots aren't helpful in the right circumstances, but I am saying that there's not a one-to-one replacement between a certified clinician or a healthcare professional and a chatbot incentivized to keep conversation going and again, really expand that consumer base. The next slide, please, Ron. Thank you. So Dane touched upon this sort of preponderance of scams and poor information, and I think that is yet another real impact that we have to attend to over time. And I do believe that we have some tools to address this point. As we know now, we're sort of living amongst this calamity of trust and this degradation of information. Though we have lived in those times for many, many generations, I don't think that there's many people who would argue that we're not seeing incredible accessibility of mis and disinformation that's truly worrisome over time. Many of us have to go a long way to avoid seeing AI tools in search bars on social media sites, and that's really fraying the availability of meaningful fact-based information that folks really desperately need. But I'm going to make a pitch, and that's that next slide, please. I ran through a lot of examples here, but there's one thing that I really want us to hold onto in this time. There are many private sector so-called solutions, these tools that are, attempting to provide information, healthcare, education, and make life easier, that are stopgaps for real societal concerns that we have to acknowledge. Many of these tools are trying to address the fact that healthcare is expensive. For many, education might be out of reach. And in many contexts, I lost my place. In many contexts, it might be difficult to make meaningful accommodations for folks at the workplace or in the classroom. And some of those solutions, some of those problems may have a sort of stopgap solution in like a ChatGPT or an AI companion. But one ask that we always ask for folks to make is that we have to be wary about what we're trading away by leaning on these short-term tech solutions rather than addressing the problems at the heart of these concerns. If we have an information gap, this is the joy of archivists and librarians and folks who really, really meaningfully, attend to our information with great care. We have clinicians that, deserve investment and like really deserve some bit of our time. So increasingly, as we're trying to find these ways to trade off this really important labor, we're leaning on the most powerful companies in our economy to define this terrain and the solution space, rather than the teachers, healthcare professionals, journalists, and other experts that we have traditionally led on for so many generations. So in other words, we are really walking into this calamity of trust and mistrust, but I think that we have a lot of ways to address that. That said, I want to leave us with a little hole that I know that many of our other speakers are going to address today, and that's on really the role for these powerful companies in the future and what we can do to challenge those narratives. Because we sort of have this, dearth that's being, or this hole that's being exploited by these big tech companies, we have been growing the use cases for which we have been plugging in, an AI tool. Worryingly, many of those tools, many of those examples have been for military and policing tactics that can easily be turned inwards just as well in a calamity of trust. And so, for those reasons, I think it's even more imperative for all of us to speak meaningfully and specifically about the harms of centralizing our public democracy, our public power, in the hands of these large tech companies, and in finding ways to circumvent that wherever and whenever we can. I'm going to finish my remarks here. Robin, feel free to take us to the next one. Thank you all so much.
Thank you so much, Maya. You covered so much in such short amount of time, and just leaving us with so many thought-provoking questions. Now I would love to move us on to Lauren's section, where she's going to discuss AI's physical footprints, including data centers. Whenever you're ready, Lauren, take it away.
Great, thank you, Robin. So behind every AI tool is a data center. Oftentimes when we're thinking about AI, it can seem really amorphous, something that's just up on the cloud. But in reality, AIs do live here down on Earth, just like us humans. They live in data centers. A data center is defined as a facility of networked computer servers used for the remote processing, storage, and distribution of data. Data centers can be used for any number of things. They're used for cloud computing. When you store something in Google Drive, for example, it's stored in a data center somewhere. So we've had data centers across the world for many years, but generative AI is driving a surge in expansion of these data centers and of their scale. Next slide, please. You've probably heard something by now about the AI race, which is sort of the modern day arms race or nuclear weapons race, if you will. There's different connections we can make, but we've seen this before. Today, it's the US and China who are both scrambling to bring new data centers online in the pursuit of AI advancement. The US is currently the largest holder of the world's total data center capacity. We've got about 54%. And much of this is clustered in Northern Virginia, which is nicknamed the data center capital of the world because it has so many large data centers all clustered in the same place. And data centers can be appealing to local, state, and federal policymakers for a variety of reasons. You've probably heard local political figures in the state of Pennsylvania, like Governor Shapiro, talking about AI, talking about the data center boom, talking about how it's a significant investment in our state, that this is the way forward, this is our future, and this is, it's the next big thing, and everyone's full steam ahead. So there's this idea that we need to win this race, and that's vital for our national security, that if we don't develop the most advanced, complex, powerful AI tools, well, then China will, and we won't have any way to defend ourselves. There's also the property tax revenue that data centers provide, which can be enticing to municipalities or to states, although sometimes states will also offer tax incentives and tax breaks to invite data centers in. And developers of these data centers will usually cite large numbers of upstream and downstream jobs. They say that, you bring the data center in, you're going to need the construction jobs to build it, you'll need jobs to provide the equipment to that data center. Although the data center itself, once the facility is built, it typically employs relatively few people. It'll depend on the size of the data center and whether the data center is co-located with an office building, but a data center on its own sometimes only has 20 to 50 workers. And considering the very large size and resource intensity of these facilities, it's not many people. Next slide, please. So a lot of us here are based in Pennsylvania, and as many of you might know, we're seeing a lot of hyperscale data centers be proposed for PA right now. This is a map snapshot, which was created by Frac Tracker Alliance, a partner organization of ours. I've had it linked below, but they have a national data centers tracker that they've been creating that'll show the currently operating and proposed projects. And so this is a look at our state. You can see there's a lot of triangles. There's a lot of proposed projects right now. And most of these are very new. Most of these have been proposed only in the past year. And we've got about 25, at least 25 by my count, large scale facilities that have been proposed just in the past year. And so why are developers looking at Pennsylvania? Well, we're a major energy producing state. We're the second largest producer of fracked gas after Texas. We have a large supply of fresh water, available land, and we've got lawmakers who are trying to advance legislation with incentives and who are pushing for this to come to our state. Next slide. But of course, we've got some concerns, especially considering the large influx of these projects, which are all competing to get online at once. So these data centers have pretty massive energy demand. One large data center can use as much energy as an entire mid-sized city, say the city of Pittsburgh. The International Data Center Corporation, or IDC, defines a hyperscale data center as having at least 5,000 servers, covering at least 10,000 square feet, and using at least 100 megawatts of energy. But many of the data centers currently being proposed will use even more energy, hundreds of megawatts, and some even over a gigawatt. For context, 1 gigawatt is enough to power 750,000 homes. So it's a pretty staggering amount of energy, and these facilities really are, there's something new. We haven't seen facilities that consume this much energy trying to come online all at once. It's a very new bridge that we're trying to cross, and in plenty of places like Pennsylvania or Virginia, where our electricity demand, it hasn't grown a whole lot over recent years, we're seeing huge projected spikes where our demand is going to increase very, very rapidly, and a lot of that demand is exclusively from data centers. Next slide, please. And as I'm sure some of you have noticed, just by looking at your own statements, electric rates are already going up. And without proper regulation, a rapid influx of large data centers will cause strain on our grid, potential for increased blackouts during peak demand, and higher electric rates for residential customers and small businesses. This is already happening in Virginia, where residents may pay $14 to $37 more per month by 2040. And part of the reason for that is the large amount of energy that these data centers use. Another part of the issue is building the new generation to support these data centers. It's costly to rapidly put up new power plants, new transmission lines, all of that new infrastructure. The utilities have to pay to build it. And when the utilities are spending money to build that new generation, it typically ends up being their entire ratepayer base who are in some way, shape, or form going to be paying for it through their electric bills. And so it's really important that we have proper regulation that will keep data centers in their own rate class and responsible for their own costs. Next slide, please. And with this great energy demand comes implications for fracking in Pennsylvania and the Appalachian region at large. These data centers use so much energy. Where is that energy going to come from? A lot of the proposals have been tied to gas. In Pennsylvania, it's been largely gas and nuclear. And so this emphasis on gas is going to increase the burden on a region that is already heavily fracked. residents in Pennsylvania can face health impacts, disturbances, stress, and decreased property values from oil and gas development very close to their homes. Pennsylvania's minimum drilling setback is a mere 500 feet, which means you can drill only 500 feet away from somebody's backyard. There's an image there of a frac pad in Westmoreland County, PA, which is where my organization, Protect PT, is based. And we're very concerned about these ties and the potential escalation in fracking activity in southwestern PA, because we see data centers and fracking as intertwined. Data centers are the perfect excuse to continue the cycle of natural resource extraction in Pennsylvania, and they might pose a significant roadblock to transitioning away from fossil fuels and towards renewable energy sources. We've already just seen high demand for electricity for US data centers, delaying the planned closures of coal plants. Our organization's members are already disturbed by fracking. They're also faced with the issue of fracking wastewater, which is highly toxic and ends up in local landfills or faulty injection wells, which sometimes fail and pollute our water resources. Overall, residents from Pennsylvania, especially southwestern Pennsylvania, we've faced a lot of harms from industry. We've faced a lot of burdens from industry. There've been a lot of boom and bust cycles. You know, the next big thing that comes through the industry uses its resources and then slowly disappears. And so we are concerned that without proper precautions, large-scale data center development may only add to the burdens that this region faces. One not so fun fact is that Toby Rice, the CEO of a gas company called EQT Corporation, which is based near Pittsburgh, has claimed that data centers will create demand for an additional 10 to 18 billion cubic feet of gas. And this would equate to 1,800 new well pads. Next slide, please. These data centers also use a lot of water. One data center can consume up to 5 million gallons of water per day, according to the Washington Post and researchers. Data centers have already become a top 10 water consuming industry in the US. This is through direct use, cooling servers, and indirect use, the electric generation that data centers require to operate. Gas-fired power plants, for example, they also use a lot of water. In fact, one 100-word email generated by an AI chatbot using GPT-4 requires 519 milliliters of water. This is more than one bottle. Next slide, please. Air, noise, and light pollution are also concerns. Data centers can contribute to air pollution via on-site gas power plants, mobile gas turbines, and diesel backup generators. Even data centers that don't have on-site gas generation and are directly hooked up to the grid will have an array of diesel backup generators. It's these data centers, especially if they're powering AI, they need to be online 24/7. And so if anything happens, these diesel generators ramp up, but they might release a lot of pollution into communities when they do so. Residents living near data centers, especially in Virginia, have complained of noise and light pollution as well. Data centers emit constant low-frequency noise, which can negatively affect health and well-being. And while the design of a data center can significantly affect how noisy it is, and the function of a data center can also affect how noisy it is or not, this is a potential impact that people may face. Cryptocurrency mines, which are a type of data center, are known for being especially noisy. They can actually be as loud as a chainsaw, which is about 70 decibels. So these are some of the impacts overall that we want to keep in mind when we're talking about AI. You know, we've got a whole host of these social, societal, information issues, but then we've also got a lot of very tangible environmental impacts on the ground as well. And that's it for me.
Lauren, thank you so much. I still can't get over one of the facts you were mentioning about how some of these data centers proposed will use over a gigawatt. And I don't know, maybe I'm showing my age, but does anybody remember a certain figure from a movie on like what it would take to time travel? 1.21 gigawatts sound familiar? So kind of think data center, DeLorean, the debate continues. Anyway. Let's move on to our wonderful Em and Nate, who will be talking about workforce and labor impacts of AI. Whenever you're ready, thank you.
All right, I'm going to kick things off for our trio here. My name's Nate. I'm a community organizer with Mountain Watershed, and I'm going to start us off with a little bit of a theoretical or historical backdrop for this section on labor and AI. I'm going to try to be brief just in the interest of time, but yeah, so let's kick things off with a quote here. This is Sam Altman here. He's the OpenAI CEO. Here he is talking at a presentation on his new ChatGPT 5 program. I'm going to read it to you guys. We used to do web development and data analysis ourselves, hiring programmers with fresh knowledge right out of school. It took 3 programmers to write and test code for a functioning application, and 3 programmers to debug and maintain it, and the product was terrific. Now ChatGPT 5 can get through 5 times as much work in a day as the 6 programmers did. Next slide, please. So that was actually me being disingenuous. This was actually a quote by Henry Ford that I manipulated to make it sound like Sam Altman, but you be the judge of how good it was. Here's the quote from Henry Ford from his autobiography, My Life and Work, about his adoption of the assembly line. Henry Ford was an early adopter of that, and it's sort of what helped him, introduce the consumer car to the American public. I'll let you read that quote at your leisure here. That's from his autobiography, My Life and Work, which ironically was ghostwritten by Samuel Crowther, which is funny. But as a bit of a next slide, please. As a bit of a palate cleanser from my candor, here's a real quote from Sam Altman, which was basically saying the same thing as the fake quote. Here he says the nature of the job, if you're say a computer programmer, shifts to manage a team of extremely junior developers. They can only do one minute task at a time. And then sometimes they'll do 10-minute tasks, and then they'll do an hour task. We can overnight make the world 3 times more software because we make every software developer 3 times more efficient. So that's sort of a bit of a primer. Next slide, please. I want to take us all the way back to middle school history here. So, I think that it's important to remember that we're agents of history, and that AI could possibly represent a major historical benchmark for the human species. No matter how you look at it, historians debate this kind of thing, but technological developments in labor, whether you want to say they dictate history or they're extremely important to the historical process. Here's just a couple examples here to sort of color your imagination. Early irrigation in the 7th and 6th century, 7th to 6th century BCE. This is what got us human civilization itself. I mean, agriculture is what allowed humans to stay rooted in a given spot for a prolonged period of time and start primitive cities. So then we jump ahead about 2,000 years, and we have things like the steam engine, the Bessemer process for steel making, textiles developments like the spinning jenny brought us factory labor as we know it, bigger construction projects, cheaper goods, those sorts of things. And then what we see at this last stop where Henry Ford sort of, brought us is automation, the assembly line, and robotics eventually. And I think this is sort of the period that we're in now. At this stage, companies can produce even more with fewer and fewer workers. That's what's bolstered, consumerism in the West and led to, sort of contributed to growth in other industries. Next slide, please. So, I just want to go back a little bit at that last stop with the assembly lines in Ford plants and other factories. What we see is labor becoming increasingly specialized. Rather than piecing together one Model T from start to finish, a worker might only assemble its drive shaft before they move that part down the line. And we've sort of seen that specialization proliferate throughout our entire labor structure. I mean, our productive processes have become increasingly complex, so delegating tasks and dividing labor can make us more efficient. More specialized labor requires less extensive training. But while efficient, it does open workers up to replaceability. That's something that we already all feel in a hyper-competitive job market. the question then is what happens when AI can compete at every level of that job market? So, I mean, this is something that people have speculated since AI sort of came on the scene in earnest, maybe 4 or 5 years ago. But yeah, I mean, here are a couple of headlines sort of coloring, how people are feeling about AI and its implications for the workforce and productivity, this elusive word. Yeah, next slide, please. So with that in mind, some experts have devised a metric, I guess you could call it, for occupational exposure to AI systems. They basically compiled like a bunch of tasks for a given given jobs, and actually created a formula that assessed a given worker's exposure to potentially their job being taken over by AI. And I think it's pretty illustrative here. These super specialized tasks are the ones that have the greatest risk for being overtaken by AI. And I do want to mention that they didn't find any significant statistical connection between job loss and AI yet, but there is sort of always the Occam's razor that AI just hasn't been, fully integrated into these types of work yet. With this in mind, I want to kick it over to Mickey here, who will talk a little bit more about the actual labor impacts of AI.
Thanks, Nate. I know we don't have a whole lot of time left, so I'll try to be pretty quick. I'm gonna throw a series of charts at you, and my apologies. I know it's not a particularly good way to understand the world to just look rapid fire at a bunch of data graphics, but let's see what we can make of them. So we're going to start with the question of who's utilizing AI for work today. If you ask that question to the world's most notorious consulting firm, McKinsey, they'll give you this answer in their recently published report from earlier this year, that while a relatively small percentage of the workers that they surveyed currently use AI for a significant portion of their jobs. In the McKinsey survey, that's 30% or more of the daily tasks in their jobs. They, by and large, expect to use AI for 30% or more of tasks in their daily jobs in 5 years or less. And that's true across the spectrum from leadership, C-suite employees to like lower ranking employees in the corporate world. Now, what possible motive could McKinsey have for, like putting a chart like this together? Or probably it has something to do with the fact that a lot of what they sell by way of their services is the adoption of AI in a corporate world. Their purpose for putting this chart together was to explain that there's a disconnect between the C-suite and the employees when it comes to who's using AI today. For me, the disconnect that I see, if we go to the next slide, is between the data that McKinsey are harvesting from their survey, and on the next slide, the data that we see from organizations like the Pew Research Center, which tends to do far more broad-ranging surveys of the American public, and just this week published an update to a survey that they've been doing relative to AI perceptions, where they found that most people in the United States aren't feeling so great about the use of AI, and in most cases claim, when they have an opinion, that AI makes a variety of different tasks that might be related to work harder or worse. So there is certainly a disconnect in perception between the people who are being consulted to by the McKinseys of the world and the people who are responding to Pew's research surveys. In the meantime, on the next slide, we see evidence that that has not slowed investment in AI significantly. While there was sort of a peak in 2021 in private sector investment in AI, that was right before ChatGPT released its public model, and sort of LLM use became widespread. we see that there continues to be massive scale investment on the order of hundreds of billions of dollars in the private sector in AI use. Now, that's been going on for years, a few years at least. And there's not a lot of, like Nate was saying, productivity demonstrated from that use yet. So if we go to the next slide, we'll see that we seem to be caught in a familiar paradox, the idea that investment has not yet paid off to the massive scale that we're seeing it with AI investment in the corporate world. And this harkens back to what we saw in the early digital era of the computers in like private sector investment in computers, where the idea of the productivity paradox first originated. Now, people who disagree with the idea that AI investment is unlikely to pay off will point to, on the next slide, the idea that investments in new technologies of substantial varieties tend to follow what's called a J curve in terms of payoff. That following the initial investment in a technology that is groundbreaking, there is a period of what they list here as underestimated productivity. What they mean is that we paid a lot of money for a thing and we're not seeing productivity coming out of it. And the techno-optimists of the world, the proponents of widespread adoption of AI, will say that we are in that period now. I do not personally agree with that, but that is like an opinion that is widespread, especially in the corporate world, especially by people who are dictating these investments that continue today. If we go to the next slide, we'll move on to one other question that I want to just touch on with respect to labor impacts, which is job displacement. And a couple of the other speakers have talked about this in various ways. If you ask some people in the world, like the organization whose slide appears, whose graph appears on the next slide, SHRM, which is a kind of center-right think tanky organization that does labor research, you'll see that, as measured on the two bars on the right, the percentage of jobs that they claim fall into a very high displacement risk or high displacement risk category is relatively small, that it's something on the order of 12% of jobs in the US. And they may or may not be right, because there is absolutely no authoritative data on what constitutes high displacement risk. Other researchers have found much higher rates, and some researchers have found lower rates of job displacement risk. But what we see in actual data is a little different. And on the next slide, I'll show you a different chart that some of you might have encountered from a very popular article that was published in The Atlantic earlier this year. It's kind of a funky chart where they manipulate a data point that's usually shown in a different way. They're looking at the unemployment rate. But in this case, what they're doing is taking the difference between the unemployment rate for recent college grads and the overall unemployment rate. So the lower the red line gets, the worse unemployment is for recent college grads. Traditionally, for decades, recent college grads have seen have had an easier time getting jobs if they are unemployed than have the remainder of the unemployed population in the United States. That's a fairly consistent gap usually. And following the pandemic, that has reversed. And a lot of people attribute this to the growth of AI and the adoption of AI by companies who, by this theory, are replacing entry-level work with AI, or refraining from hiring new workers in the hope that AI will be able to do the job of entry-level employees. And as Dane talked about earlier, that begs the question of what happens in the future to what starts as an entry-level position and becomes a higher-level expert. But in the meantime, it's also starting to become an unemployment challenge in the very present day for college graduates. We also see one more thing on the next slide with respect to who's affected right now. Somewhat ironically, what seems to be the most affected sector from the current developments is the tech sector. Technology workers are being, there seems to be evidence that technology workers are being displaced presently, and it is logical to assume, in my opinion, that AI is behind a lot of that because of the fairly direct applicability of a lot of these models to programming tasks and software development. So right now, if we go to the next slide, I'll close with a quote and then throw it to him. I disagree with a lot of Sam Altman's sort of worldviews, but he starts a very famous essay that he published earlier this year talking about how the singularity is near, meaning that a super intelligent AI is coming soon to a chatbot near you. And he opens the essay with this line: "We are past the event horizon. The takeoff has started." And I don't agree with the intent with which he, continues his essay, but I do agree with that idea. I think we are starting right now already to see the effects in terms of workforce from the presence of AI in companies. I'll throw it to him to talk about a very different workforce that's part of this AI economy.
All right, thanks, guys. Yeah, so I want to talk about an often ignored aspect of the AI build out that I feel is pretty important. And that is the issue of the data labeling and data labelers. So when most people think about AI, they imagine a machine that can learn and act with complete autonomy. But the reality of it is that the technology requires a significant amount of human labor to complete even basic functions. And this invisible workforce is what referred to as data labelers. Which they are the architects of AI success and ensure that models are not only accurate, but also ethical. Data labeling is a process that where people annotate data sets to make them understandable for machine learning algorithms, which involves identifying and tagging raw data. So things like text, images, videos, or audio with relevant labels. For instance, a labeled data set for facial recognition might include tags like eyes, nose, or mouth, while labeled images for autonomous vehicles might identify stop signs, pedestrians, or road lanes. Without this labeled data, AI systems would not even be able to differentiate between a dog or a cat, let alone predict stock market trends or diagnose medical conditions. This data labeling is crucial to building the foundation of machine learning, scaling AI innovation, improving accuracy, and supporting ethical AI development. However, this process is time-consuming, it's labor-intensive, and it is mentally exhausting, and large-scale projects require labeling of millions of data points, and a single error can impact the accuracy of the model. Additionally, data labelers must sift through text, photos, and videos that are often violent or disturbing in nature in order to categorize this content accurately. Despite being an essential component of AI development, the people who do this work are often underpaid and subjected to exploitative working conditions. Next slide, please. So perhaps unsurprisingly, a lot of this exploitation takes place in the global south. Tech companies that are based in the global north frequently outsource tech work like content moderation and data labeling to countries in the global south. And unfortunately, these jobs are rife with exploitative practices and unfair treatment. Data labelers are massively underpaid, often earning just cents for tasks that take many hours to complete, and there have been many reported instances of wages being withheld. Screenshots shared by Kenyan data labelers revealed that in the worst instances, data labelers have been paid nothing for over 20 hours of work. Additionally, labelers lack formal employment contracts and have no long-term job security. They don't have access to healthcare, pensions, or labor unions. Data labelers also cite content moderation trauma as a major concern, as their work frequently brings them into contact with graphically violent media, hate speech, and pornographic content. And despite being inundated with these traumatic images and text, workers are not provided with mental health support. One data labeler reported that when she expressed concerns about her mental health and asked for support from her company, they recommended that she simply watch happy videos for 30 minutes a day to balance out the content that she was seeing on a daily basis. These poor and unfair working conditions led 97 Kenyan data labelers to pen an open letter to then President Biden in May of 2024 in advance of a meeting with Kenya's president, referring to their condition as modern day slavery. They asked that the US big tech companies be held accountable in the US courts for their unlawful operations abroad, in particular for their human rights and labor violations, and that they be subject to the core conventions of the International Labor Organization and provide serious enforcement mechanisms and meaningful penalties to lawbreaking companies. Additionally, the letter called out the intense union busting in the digital sector. And as of February this year, the workers in Kenya launched the Data Labelers Association to fight for fair pay, a union, mental health support, better overall working conditions, and recognition for data labelers worldwide. Next slide, please. And so quickly, I want to touch on techno-colonialism and colonialism more broadly. I would guess most of us know that colonialism is the subjugation or political control of one people by another that can include things like settlement, economic exploitation, and resource extraction. Techno-colonialism is a term coined by Mirkna Marianu, a professor and co-director of the Migrant Futures Institute at Goldsmiths University of London. Techno-colonialism offers a broad lens through which we can view AI build-out. Her research primarily focuses on how colonial mentalities and practices are expressed through tech and AI use in humanitarian crises, such as algorithmically determining aid recipients and AI being used to predict refugee flows. She demonstrates that digital innovation and AI entrench power asymmetries between the global north and south, especially when there is an assumption of neutrality with regard to AI tech. When tech companies in the global north outsource labor to the global south in an effort to pay less in wages and avoid fair labor laws, this constitutes a form of techno-colonialism under the guise of empowerment. There has been a huge uptick in NGOs run by AI companies that specifically target refugee communities to recruit for data annotation work. One such platform sports the motto, "Give work, not aid," and refers to this work as the virtual assembly line. Many individuals who work as data labelers and content moderators have no other alternatives for work, in large part due to the long history of colonial exploitation in their countries by Western nations. And this labor exploitation in the tech realm reinforces these international hierarchies at the expense of the physical and mental health of the workers that enable these AI projects to exist in the first place. Next slide. And then here's just a small collection of article headlines that I found in my research in putting this presentation together. So that's all I have. Thanks.
Wonderful. Thank you so much to Nate, Mickey, and Em. In the essence of time, I will speed along the last section of the presentation, mine, where we'll discuss local, state, and federal regulation. I'd like to start out here about talking about local level power and how you can get involved, and that starts out with local zoning matters. Here on the screen, I have a map back from 1926 of Euclid, Ohio. And why am I going to be talking about this? Because this is pretty much the birth of American zoning. In 1926, the US Supreme Court made an important decision in a case called Euclid versus Ambler. The court ruled that the village of Euclid, Ohio had the right to limit industrial development in order to protect nearby residential neighborhoods. This ruling gave cities and towns across the country the green light to create zoning laws, rules that control how land can be used. These laws, often called Euclidean zoning, after this case, quickly spread throughout the United States. And over time, zoning rules have become more detailed and have placed stricter limits on how private property can be used, with courts generally supporting these growing regulations. So TLDR, municipalities can shape the kind of communities they want now and for the future. Municipalities can direct local control over how land is developed, ensuring that local voices are heard and local priorities are respected. And local ordinances have the greatest, most immediate impact on residents' daily lives. Why are we talking about this? Because of what Lauren was chatting about earlier with data centers. So quickly, like I said, in the instance of time, I won't wax too poetic about this. But for example, in Pennsylvania, communities across Pennsylvania are fighting back against the rampant data center expansion with local zoning. Our governor here has said that we are going to be one of the top states in the entire United States for AI and data center development because of our natural gas resources and our land use. Pennsylvania communities and communities across the country are fighting back with data center ordinances where we can I don't want to say regulate, but like we can say we can impose stricter regulations, more protective conditions on such as water usage, noise, and light. And these can be all wrapped up in a pretty package that is specifically for data centers. Because a little trick, at least within Pennsylvania, if you do not accommodate a use in your zoning code, rather than saying, oh, you can't have it in your area, the data center or the company or the industry can say, you have not provided a space for me, so I get to pick the space. So one way to combat that is to immediately have zoning regulations for where it can go and how loud it can be, how smelly can it be, and things of that nature. And we will be producing copies of model data center ordinances that organizations, including several who are hosting this event, have created as templates for local municipalities, as well as checklists on what to look for. Also, a way that people in Pennsylvania have been combating these data center ordinances with the rampant expansion is knowledge of local protocol and meetings and public hearings. Recently out in, I believe, Luzerne County, Pennsylvania, a public hearing will have to be restarted because it wasn't properly advertised. And that is why I don't want to say the devil's in the details. I want to say like the delight is in the details, because without that, they could have rammed through a public hearing to approve a data center ordinance without giving the public much time to speak or even really know more about the public. So always check out your details. Very wordy slide. I promise I won't go through it all. Plus, you'll see this during the recording. But local zoning Virginia examples, like we said earlier, Northern Virginia is currently being like the world's largest like data center development. And in the absence of the new statewide rules, localities were left to manage these data center impacts on their own, and has led a patchwork of regulations across the state. But this has also showed local empowerment. So for example, in Loudoun County, excuse my friend, Albemarle County, and also Prince George's County. You can read those later on to your leisure, but basically instead of having a statewide regulation because Virginia's legislators failed Virginia in having more statewide regulations that would have protective markers in place, it was now left back to the local municipalities, which honestly, local power is your most powerful power out there. Moving right along. Local level power, engaging your community, making sure that your community and your leaders are educated about AI, resource sharing, sharing this webinar, sharing fact sheets, anything that you possibly can through any means possible, offering to host local meetings or additional webinars or anything that can be approached, bringing this up during public meetings with your commissioners or your council members about your concerns. The more that you spread the word, the more people can engage in the dialogue and really get a feel for what's going on instead of feeling like they're being bamboozled by a bunch of tech companies or anybody that might not have the public interest, but rather just private interest. Additionally, part of this is challenging the misinformation on data centers. A lot of the times data center developers or, sorry, even lawmakers will come and say, oh, we need this for the medical uses, you know, mentioning before what Dane had said about the incredible medical advances through AI, or cloud computing, Netflix streaming. One local lawmaker during our data center hearings here in Pennsylvania had said, it's because since everybody's streaming Netflix so much, or Disney or Hulu, or anything like that, we are forced now to have these data centers because you guys are just using way too much energy and we need to speed this up. But in reality, it's for an LLM. So always challenging the rhetoric against what it's really for and things like that. I want to zip on over to now awareness of state and federal level legislation. And just very quickly, some examples of current state level legislation, not including but not limited to West Virginia's House Bill 2014, which was what is called the Power Generation Consumption Act, that was signed into law back on April of 2025. This law creates a certified microgrid program that's designed to attract data centers and tech companies to the state. But what this really translates to is a sweeping energy bill that would strip local governments and regulators of jurisdiction over data centers sought by the legislation, while propping up increasingly costly coal-fired electricity. Moving on to Pennsylvania quickly, Senate Bill 939. This is an act providing for high impact data centers, establishing the Office of Transformation and Opportunity and the Artificial Intelligence Data Center and Emerging Technology Regulatory Sandbox Program. What a mouthful. And providing for powers and duties of audit office. Senate Bill 991. This is an act for a permitting process for data center siting and imposing powers and duties on the Department of Environmental Protection, basically trying to take away local power for siting on data centers. And one that's been particularly spicy that's been in the news here is PA House Bill 502, which is an act that would amend Title 27 environmental resources to establish the Reliable Energy Siting and Electric Transition Board, also known as the Reset Board. This would be a bill that would fast track fossil fuel projects by overriding local government control and public input. And as we had mentioned earlier, that most of these data centers in many areas of the country, but particularly Pennsylvania, would be running on natural gas. So basically, this is a bill that I will be controversial, but it is pretty much unconstitutional, as it would override local zoning powers that are established in the Commonwealth of Pennsylvania. Later on, during our follow-up email, we will have a series of information and actions that you can take if you are concerned about this and if you live in any of these states, particularly Pennsylvania. But for the sake of time, we are going to move on to federal regulations. Just a little caveat here. I wanted to put up that this is directly from the White House and the current presidential administration, and I put the links there to say that this is flat out what has been happening since January of 2025. I won't read aloud all of them, but I do want to draw attention to the very first executive order that happened on January 20th, 2025, which was the initial rescissions of harmful executive orders and actions. And one of those that was considered harmful was the executive order on October 30th, 2023, that was called the Safe, Secure, and Trustworthy Development and Use of Artificial Intelligence. So something that was, in theory, that was supposed to try and have safe and secure development of AI was deemed dangerous and has been erased. These are a few other executive orders by this current presidential administration that you can read later at your leisure if you so desire. And in July of 2025, the current presidential administration revealed America's AI Action Plan, with policy notes including exporting American AI, promoting the rapid build out of data centers, enabling innovation and adoption, and upholding free speech and frontier models. Wow, that's all I will say about that. And below are the accompanying executive orders that were within that notice and this plan. But as we have seen here, this really is going to be related to massive energy and water intensive data centers, and amongst other things. This plan also seeks to dismantle existing environmental and land use rules that it views as a hindrance to unfettered growth of these industries. And as we previously mentioned, the immense and potentially catastrophic impact on water and energy resources on unfettered AI industry could have on communities across the country. especially those out in the West that we haven't talked about much, but I apologize, but for the sake of time, we hadn't had a chance to talk about that more. But as Pennsylvania and other areas too, if you're around this area, we are experiencing increasing drought, as is the entire country, as we move towards either having deluges of rain and flooding or extreme drought. Energy demand from these AI servers and data centers in the US is expected to increase up to threefold between 2023 and 2028. And we will just end with that. And here I'm going to stop sharing the screen. And if our lovely presenters could come on camera, if you feel comfortable, this is the chance for us to start our Q&A session.
Thank you, Robin. And I'd like to apologize to folks for us going over, but I think it was content worth like sharing and discussing. If people are able to stay on, we will do our best to answer these questions. We have been answering them in the Q&A box, but all of the questions will have answers in a follow-up email to everybody with the recording after this as well. And if we have the ability to, we'll sort of touch on some of these because I've sorted them by subject for our presenters, so that they're available in the recording, even if they were answered in the Q&A box. That's our goal here, but bear with us since we are over time. Something I want to start with, just based on the types of questions we're getting in the chat, is the subject of AI and society. And this question was a little bit later, but I just think it would be great for folks to sort of comment on what can we do. It says, if I don't have a data center planned in my backyard, what are my concerns and responsibilities for AI? Who would like to jump on that one first? Go for it, Maya.
I can make an attempt at this. I know there's going to be a lot of disagreement on this. There's disagreement even within my colleagues and I, but I think one interesting thing to do, and we've been like experimenting with this as a team, is to, I think there are a lot of narratives that view sort of AI adoption as a foregone conclusion, and I don't know that I don't know that that's always true. I feel like there's lots of ways that one can, talk to folks about the expansive harms, really try to build this kind of counter narrative and try to resist where it's possible. Just to name a few examples, um, there were a few months ago, earlier on in the summer, Google just sort of like released Gemini for all Gmail clients possible. And we took it down for our organization because we thought, okay, well, it's reading our emails and we are researchers and that's not appropriate for this task. So I do feel like there are opportunities where, it might be the stickier thing, but it, could be worthwhile to really examine whether it's necessary and helpful. And if not, like think about other ways to address productivity in one's life. But that's just one that I'll throw out here. I'm sure there are others that other panelists have top of mind.
Thanks, Maya. I saw a second hand. Who else wanted to say something? Okay. I will also just jump in and share that as someone who's organizing around the environment and health, if you are concerned about climate change, then being concerned about this is something relevant to you. Whether or not there's a data center in your backyard, it's still being powered, especially in Pennsylvania, by fossil fuels, pumping carbon into the air and making your weather worse as well. So although fighting at the local level and working in your backyard with your neighbors is a really impactful way, if you don't have a data center right in your backyard, search around to understand the implications that are environmental that you may be concerned about, as well as the education concerns and some of the other things that we've discussed around the harms that AI in the wrong hands, i.e. the powerful hands, is being applied to folks. I'll pass it to Tamala.
Yeah, thank you, Josephine. So I interpreted that question just a little bit differently. I in my work with Move Past Plastic, wanted to keep different environmental issues kind of off my plate until it came to my backyard. So you never know when and if a data center is coming to your backyard. And so it's best to try and reach out to your municipality to get ordinances and zoning and protections in place beforehand, before a data center comes and aggressively tries to seduce them with tax revenues and not much use for their local services. So that's what I recommend. And there's lots of groups out here, and you'll be given this information after this is over of support and model ordinances and protections.
Thanks so much. Okay. The next one I'm looking to see which ones have not been answered yet on the Q&A. Let's talk about the economics, because we had several questions on economics and none of them got answered in the Q&A. I think partly because that's not our expertise, but we can do our best. One of the questions was, what are the stranded asset risks if AI boom and bust cycle mirrors previous tech bubbles? Does anyone have something they'd like to add to that one? Go ahead, Tamala.
Other than just, the huge infrastructure that may be built and all the servers that may be there, the diesel storage tanks and ethylene glycol tanks, and yeah, just the infrastructure, which is why including a decommissioning clause is also important.
Yeah, and a good example of that in Northeast PA, we recently reviewed PJM's expansion project committee, and just the projects for data centers for expansion of electricity in Northeast Pennsylvania alone was 5.5 gigawatts, which is enough to power nearly all the households in Pennsylvania. We have 5.2 million households in Pennsylvania, and that use approximately 5.5 gigawatts. So just like building all that infrastructure, especially with all of the additional pipelines and fracking and pollution that would cause because of our state basing it on oil and gas, that puts society at a huge risk. And then, yes, you have all of those stranded data centers that they'll try and come up with a different way to use or utilize or justify, or it becomes massive waste.
I'll just add on to that. I mean, the risk of like loss within the labor market, it's not probably what the question asker is getting at when they say stranded assets. But when we invest in terms of how we spend capital towards developing a workforce, when companies invest in AI systems that displace workers, the ramifications of that in terms of people's careers are measured in decades, and the potential cost to very heavy investments in AI systems that displace workers will accrue to people who are displaced to the extent that that takes place.
Thanks, Mickey. Okay. One more question that's related to that is, what are the probabilities that any of the proposed hyperscale data centers will materialize? Are most of them either one, an outright scam on investors, or two, just a fossil fuel energy project which will be built and then justified by a data center? As far as the boom and bust and the bubble that we have been talking about, and especially in Pennsylvania, the fossil fuel boom that's trying to be tagged along and tied with it, what kind of thoughts, comments do you have, folks, on the probability of these materializing? We did discuss a little bit the impacts of stranded assets, but feel free to add anything to this.
It's an interesting question because we have obviously the example of Homer City, that, is in the permitting process right now, that doesn't even have a tenant lined up for their data center. So while I don't have an answer, I do just want to flag that, many of these proposed data centers are being built without you know, clear ideas about demand for actual computing power. Like, if you don't have a tenant lined up, why are we co-locating a data center at the site of the largest natural gas power plant in the country? Yeah, that's an interesting question that I haven't actually given too much thought to.
All right. And on the topic of governance and regulations, do you think regulations can help prevent some of the potential dangerous consequences of generative AI, such as being used to generate fake data with the intent to cause harm, deep fakes, fake evidence, etc.? Or are these consequences inevitable of the technology?
It's not a future looking question. Like those things exist today. Um, and the technology has advanced enough and become sufficiently available that those uses are already to some extent in existence. I think regulation is an important part of mitigating that use. But I think to echo Altman, like we're in it already, like I don't agree with his vision for whether or not we should be, but we kind of are. And I think people who are advocating for regulation need to do so with a realism about what exists out there in the world by way of AI models right now.
Thanks so much, Mickey. Related to that, what regulatory loopholes allow AI facilities to avoid proper oversight? I also think that this question is talking about data centers too. I know, I mean, some of the things that you talked about, Robin, where they're trying to give them more loopholes in our state, in Pennsylvania here.
Yeah, absolutely. As we are seeing more and more legislation that where there wasn't local control explicitly stated, or in Pennsylvania where it is explicitly stated, but they're like in the essence of fast tracking projects to stabilize the grid, energy projects here, anything like that. Those are some of the ways where they're saying like there's an absolute need for this. Local municipalities may not fully. It was actually really insulting, and I promise I won't wax poetic. How saying like how local elected officials may not understand the complexities of some of these projects that require fast tracking and assessment from experts in the area, and how don't worry, the reset board or the siting board will still value community input because this will be in the form of community meetings, which really means they are just going to override the public hearing process and robbing people of their due process. So these are some of the ways that they get around things. You might see more and more with data centers, even though there is a land use, which means actually more regulation can happen, as opposed to like in industries such as fracking, where we are here in Pennsylvania, we are, for better, for worse, sorry, by the PA Oil and Gas Act, where some of the local zoning ordinances, they say are doing some overreach by saying that the conditions in the local ordinance are interfering with the how to drill instead of where to drill. I would not be surprised if we start seeing more legislation and how protective ordinances would start. They would be saying like how these would be infringing on the how to run the data center rather than where to run the data center. So we shall see. There's always sneaky things going around.
Thanks, Robin. And I think that sort of also answers the question, where does governance happen? Who decides? As well as the question, what municipal and state policy options are there for limiting the growth of data centers? We will obviously share more resources in the follow-up. I will plug again the same resource that I shared before, which is a working draft document of a template that talks about some of the potential regulations you could at your local level pursue to preemptively regulate these facilities, whether or not you have one proposed for your area. And one of the things is like with House Bill 502 and some of these others, they're going after these municipal ordinances because they do have an impact and they're in the way. So that means you should utilize this power that you have, because pressuring your township supervisors is a little bit easier than pressuring the federal government, i.e., the steps in between. There's layers, and we should work at all levels to, pursue something that is both safe for human health and morally like supportive for human life and enjoyment. And at the same time, like, don't feel you need to take on the entire world if you can make an impact at your local level. So I just want to encourage that you can get started locally, and it is really important and it's appreciated. Okay, I know we're almost at out of questions that haven't been answered. We will follow up. There was one environmental question we didn't get to yet, which is, can the water be used that's used for cooling data centers be reused and recycled? And I can add a little bit to that. Only about 5% is recycled water. One, a lot of it's evaporated, and two, polluted, i.e., reused water, even when cleaned, that water that's not potable, i.e., not perfect for drinking water, corrodes and impacts the equipment that they're cooling, and they don't want to ruin their equipment prematurely. They want to increase the lifespan of that equipment. So they typically go after municipal water authority sources or stuff that's treated that is what we would want to consume, which is why wells are drying up and you see those other impacts in communities, because they evaporate a ton of the cooling and waste that water, but also are after the water that we can drink, which is a very small percentage in this planet. All right, I'm going to throw one more at you all. Sorry about the rapid fire. And we will be linking the sources that Dane referenced on climate tracking and all of that. Go ahead. I see you, Tamla.
Just super, super quick. They have the closed loop systems for water, so they use less water. But just if they use those, then they're going to be having an increase in energy. So that's kind of they're inversely proportionate to each other. And so then that means more generators, more diesel fuel being stored, more air particulates, etc.
Thank you. This one was partly answered by Dane in the chat, but I think it's a good one to end on because this is a discussion on AI and society. Is there any research, and what do we have on how this reliance on using ChatGPT or even just using Siri have on people's ability to learn and practice and need their basic skills? So we talked about the loss of like the professionals and the experts, but what about just day-to-day tasks where you're not you don't remember your times tables or whatever, like to make a tip, or you're whipping out your AI to look up something that you should just know, or it's a skill you don't have, like making a recipe. Do we have any commentary on the over-reliance on this type of technology?
Our brains are plastic. If we have a resource available to us that can do a task reliably for us, then it is human nature to just rely on that thing instead of use your own brain. This happens in relationships with husbands and wives offloading parts of memory to each other. And I think it's absolutely natural that it would happen with AI, but I think it's much more dangerous, because what happens when you get cut off from it? But yeah, how do you fight against that? Apart from interacting with the AI in a critical way, asking critical questions and making the AI oppose you as opposed to just agree with you. I am not sure what can be done at a systematic level.
Go ahead, Tamla. Thanks, Dane.
Yeah, so it's kind of use it or lose it. Your brain is like the other parts of your muscles, your axons and dendrites, neurons. If you don't use those network connections, then you will lose them. And then, like Dana was referring to, when you need them, you won't have them accessible. So brain mush, basically.
All right. We are at 8:32. Is there anything else anyone wants to comment? Thank you so much to our presenters and panelists. I'll turn it back over to Robin if no one has any other main questions. Oh, yeah, go for it, Robin, on renewable energy. Definitely talk about that. I'm sorry, I missed that one.
No, no worries. You have done a phenomenal job of herding the questions and really organizing. Thanks so much to you and Tamla for that. Just real quick, noticing what is the challenge of renewable energy sources for data centers? Extremely short answer that we will expand on our post-webinar follow-up email is that it has to do a lot with the amount of space the renewable energy takes up and can for better or worse, what industry or the state considers as a reliable energy source right now. But as of right now, like talking about, I don't want to start talking about exact facts and figures because I would rather save that for the post-webinar follow-up email. But when we start comparing the use of solar energy and what like the land is needed for the solar panels versus this is the argument, this is not what I'm saying, the land use for solar panels versus what natural gas can produce, like a well pad can produce, they would say that they would take so much more land for the solar panels or the wind turbines or anything like that. But as we know, we are constantly making advances, and really, at least in Pennsylvania, seems to be a just another way to kind of perpetuate natural gas into its many different forms. I don't know if my other colleagues would like to comment on that, but we can definitely have a more expanded answer on that in the follow-up email. Nope. All right. I just want to extend a huge thank you again to our presenters, my colleagues, and to everyone who attended tonight for sitting through such an intense and valuable webinar. There were a few comments saying, next time it'd be great to have this as a Zoom meeting style. We agree. We love interacting with people, just with the amount of content that we had tonight and with the amount of time to make sure that we could get through as much as possible without having people having a ton of Zoom fatigue. But this is wonderful for our next event that we'd be very happy to have. Like we said, some of the slides were skipped in the essence of time. They will be included in the post-webinar follow-up emails, such as actions that you can take, groups that you can meet up with, such as like PSRPA, Protect PT, Food and Water Watch, anyone who are having local working groups working on some of these issues. And as always, we'll be sending the recording, the slides, the follow-up email. And if you have any questions at all, please don't hesitate to reach out to us. And we look forward to next time. Thank you all so much for a wonderful, thought-provoking evening.